Hello, welcome to Embedded Systems Practical 6. We are continuing with our home automation series. In today's practical, we're going to be dealing with the design and construction of an automatic door activated electric power switching system for lab and workshop. So what you are seeing here is a completed hardware, and also the software is also, I've also finished the software and I've uploaded the program here. So let's take a look at this. Now before we go further, I'm going to explain what this system does. Hello viewers, if today is your first time of coming across this my YouTube channel, please like, share and subscribe. If you haven't watched my previous videos, please go back and watch them. I've done videos on electronics and embedded systems. So the automatic door activated electric power switching system for lab and workshop. Now what made me to design this system? Just as I have mentioned before, there is a very big difference between academic knowledge and real life theoretical and practical knowledge. Based on personal experience, we live in a part of the world whereby electric power is not guaranteed all the time. Sometimes your grid power comes on and sometimes it stays off. So I have observed that sometimes after the day's work, I will close my workshop, lock the doors, and sometimes I will forget to turn off the main power switch supplying electricity into my workshop. And in the middle of the night, our grid system comes on and the load in my workshop will come on, which is not good. Which is not too good. So now I've designed a system whereby if I close the door of my workshop, the system will detect that the doors are closed and the main power switch supplying electricity either to some of my appliances or to the entire workshop will be automatically disconnected, so that in a situation whereby I forget to turn off the main power switch to my appliances during power failure, so that when the power is restored, when I am not around, that is after closing the doors, locking the doors, and I'm away, this will prevent power from coming on and powering my appliances are on, which is not good. So which is what made me to design this. So what we have here is solving a real life problem. So you are traveling, you forget to switch off power to your house or your workshop or your lab. So this system will make sure that everything remains off. The electric power, either it could be AC or it could be DC. Make sure that power feeding loads in your workshop or your lab is automatically turned off when the door switch, just like as I'm seeing here from the block diagram. So we have a door sensor switch. It's just the same principle with a push button. Then we have one push button here. Then we have your microcontroller. We have some LED indicators. We have your relay driver. Then we have AC, DC power supply. And then to your load could be either AC or DC. So so let's take a look at the system here. So what we have here, let's take a look at a block diagram here. So here our door switch is going to be connected here. This, I just put this for demonstration. It's just that I'm not with the door switch physically here, so I just put this switch here to for demonstration purposes, but I'm still going to connect it to the door sensor switch, which I don't have with me right here. So I put this to represent the door sensor. So this action means that the door is open, so this action means that the door is closed. So I'm just going to use this to explain the circuit here, so which I'm still going to replace the actual door sensor there. Then I have a push button. What we have here is so what we have here, this is a push button, which the one we have here, so that if you are inside the workshop, let's say you close the door and you are inside, before the system will automatically deactivate the power switch, pressing this button, you are telling this system that you are inside the workshop, the power should be left on. You understand? So immediately you press this button, it's not going to turn off the load, so to signal this device that you are inside the workshop but the doors are closed. So here we have our relay. And see on our diagram here, so this is a 12 volt 15 amps relay I put here. Then this is the wire to the load you want to power this relay. You want to switch with this relay. Now if your load is more than 15 amps, because this relay is 15 amps, make sure you use a higher relay. You understand? Like for this relay now, I can use this to power my appliances, but if I'm going to use this to control the power to cut off or link up power to my workshop, I'm going to use this relay to power a contactor, a bigger relay. You understand? So if your load is less than 15 amps, you can just use it directly. But if your load, let's say something around 100 amps, everything in your workshop, let's say, so you use this relay now to switch the contactor. You're going to connect, you use it to connect to a contactor in series with a conductor and the power supply. So this is what we have here, our relay driver, which is going to switch your load. So, and then I also have some LEDs that will be indicating that there is power to the board. And then here we have the microcontroller here, the microcontroller. So this STM32 microcontroller you are seeing here. So let's take a look at the circuit diagram. Let's take a look at the circuit diagram here. So this is the circuit diagram. Now here we have the door switch. You know, when you close the door is going to press this push button. You're going to press it, and you're going to receive logic 0 on this pin. The microcontroller is going to read logic 0, indicating that the door is closed. Now if you have multiple doors, you connect all the switches in series, so that it is until when all the doors are closed, then you're going to sense 0. But if you just have one door, you just connect it this way. You understand? So this is the STM. Just like I said, I use STM32F103C8 microcontroller. Of course, you can use any microcontroller to do this, but this is just my own choice of microcontroller I decided to use. Arduino Nano, Arduino, anyone you can use, to ESP32, LGT, you can use any of those microcontrollers. So I decided to use this. And then this is a push button to tell the microcontroller. For instance, the weather is not good and we have very high wind and you are inside the workshop and you decide to close the door and you are working inside the workshop. The system, instead of the system to disconnect the load, pressing this button, you are telling the system that don't turn off the power, don't turn off the power, leave the power. You understand? Which means this relay is going to switch this way, so you're going to be allowing power to go to your load. Then we have an LED indicator. Now this your DC 12 volt. This circuit is powered with 12 volts. You understand? This is powered with 12 volts. With this 5 volt regulator. This board, your STM32 board, the actual microcontroller on the board is 3.3 volt, but there's a 5 volt regulator on board, so that's why I'm using my 5 volts. Remember our protection, Zener diode, non-polarized and polarized capacitors, 1000 microfarad, 100 nanofarad, and 5.1 volt Zener diode. Then this is your indicator LED to show that there is power. You're connecting 12 volts here. It is going to. So here we have our relay. Our relay is driven through an NPN transistor. You understand? So as long as the doors are open, you understand, it means that the workshop is in use, so people are around. You understand? So in moment, let's say you have closed for the day and you close your door of your workshop, the door is going to press the switch down. Then if you forget to turn off the main power in there and there is power, the microcontroller is going to detect that the doors are closed. Then it's going to flash this LED here 10 times. After flashing that 10 times, during the flashing of that 10 times, if it doesn't detect any press on this, after flashing 10 times, it is going to deactivate the load. So this is the main supply going into your workshop or to whatever appliances you are powering with this. You understand? Now use the relay size of the relay according to your need. Here I just decided to use 15 amps. You understand? If you're depending on your load, use the relay according to your load requirement. So if the door is open, the microcontroller is going to flash this LED first. That's when you power. When the power is supplied to your workshop, it will detect this switch is open. It means the doors are open, people are around. So it's going to flash this LED 10 times. After that, it's going to switch on power. So here is going to your lab or your workshop or whatever load you are powering with this. You understand? So that in a situation whereby there is great power failure, there will be no power here, and you are leaving the workshop, you have closed for the day and you close your door is going to press this switch. And in the event that you forgot to turn off the main power to your workshop or lab, you forgot and you went home, then let's say later and the grid power is restored. So what is going to happen is that once this thing boots up, it's going to sense this, check whether if this button is closed. If this button is pressed, indicating that the door is closed, so the microcontroller is going to flash this in 10 times and make sure the relay is off. Like with this position now, the relay is off. That means there is no power going to your load. You understand? But the moment the doors are opened, it will automatically turn on this relay. That's after flashing 10 times, and the power, there will be an output here. You understand? So this is your power. So now your load could be AC or DC. So if you are using your AC power is AC, your loads are AC. If your power is DC, that is depending if you are powering the loads in your workshop with DC power or AC. So whichever, depending on your own needs. You understand? Now in a situation whereby you people are still in the workshop, you all decide to close the doors, but if people are inside working, you press this button to tell the microcontroller that do not disconnect the load, leave the relay on. That's what it means when you press this. So the moment somebody opens the door, the system is going to restart the sequence. You understand? So this is just how the system works. So let me power. I'm going to power it. So I'm going to power it. Oh, my push button I've removed. Let me connect this quickly. So I'm going to apply this is my 12 volts input, 12 volts. So I'm going to supply power to the board. So you see so you can see this is, you see this LED here is connected to the relay. It means that the relay is on. You understand? The relay is on. So now I'm going to, this shows, this indicating that the door is open. So what I'm going to do now, you see this LED here, this LED that we have here. So let me put it this way so that you can see it. So now I'm going to close the door now. So let's say I've closed the door. You can see the LED is flashing. It's going to flash 10 times. After that, it will shut down the relay. So you can see the relay is off. So as long as the door is closed, you understand, as long as the door is closed, the relay is off. So it means power supply to your lab or workshop is cut off. So now the door is open. You see, also going to flash, so that in case maybe you just so that you should not be toggling the switch so fast. In case you close the door back again, you open, so you can see, so that it doesn't. So it's going to flash, and then it detects that the door is open, so you can see the relay is on. So each time the door is closed, it's going to flash 10 times. You understand? So each time the door is closed, it's going to flash the number of times, and then so you see, so the door is closed. So let's say you have closed your workshop. Now let me cut off power. Let's say, assuming now this condition, now there is grid power failure, and later let's say now there is grid power. So the system is going to check if the door is closed. If you detect that the door is closed, it will make sure that no power flow into your load or into your workshop. So you see, it makes sure the relay is off. But the moment the door is open, So you see, it will check and then turn on power. So you see, so let's say I close the door and I'm inside the workshop. I'm going to press this push button. So you can see I press this push button, I'm inside the workshop, so it's not going to turn off the load. So that's the function of this push button here. So you see, that's the function of this push button. I'm inside the workshop, I close the doors. So instead of the system to shut down the power, it will leave the power on. Let's say I'm inside the workshop, I don't want to go home, I want to stay and work, but why the doors are closed. So you see, so each time, let's say I stayed in the workshop, I work overnight, and the morning I want to rush home to go and prepare, I open the door, and it's going to allow power to come, and then I close the door. I want to rush home and take my bath and then come back. I've closed the door, so it will make sure it will still flash and make sure that the power is off. So you see, so as long as I've closed the workshop door, it will make sure, and I did not press this button, the microcontroller would not know that there is nobody in this workshop. The workshop is closed, the doors are locked. So which means I need to turn off the power. So you see, so that's just the intelligence in this system. So you see, that's just intelligence in this system. I wrote the program in Arduino C programming language, which I already, so you can see the program running here. I developed it with Arduino C programming language. Now I have made something that will solve a real life problem. Now you can take a look at the circuit diagram. You can design yours. You can add whichever features you want to add to yours. Take note of this. Take note of this, as I mentioned. Your load, you can take this into, for example, now if you have a AC air conditioner in your workshop and heavy high power loads, please don't take this, don't power this the loads directly with this. Use a heavy duty relays or contactors. You are going to use this to, the contactors will act as a load now to this relay. So which means you are going to, let's come down to our circuit here. So if your loads are very much heavy loads, more than 15 amps, just like what we're having here, if you can't get a relay for, like, let's say 100 amps or 200 amps relay, and if you have contactors, you connect, your contactor will be here. Do you understand? You have a contactor here, so you use this relay now to switch the contactor. Then the contactor will be the one to switch your loads. Do you understand? So if you have heavy loads in your workshop, you can't connect them through this way, like this. So you power them through a contact. Your contactor will be here. So your contactor now will be the load now in this case. You understand? So the contactor will be the one now to power to switch your loads. So that's how you make this. So we have this hardware and software. Now take note of this. A software residing in a hardware in embedded system, we could refer to it as firmware. So the computer program running here, we refer to it as firmware. You understand? So please like this video, share it, and also don't forget to subscribe. I will be making much videos that will be solving real life problems. So you can go and practice this. You can go and practice this. Now let me now something like this. Now, how do you write your program to this? Now take a look at this. Here is digital input. Here is digital input. Here is digital output, here is digital output. That's what you need to know. Now writing this program is very simple. Tell the microcontroller if you detect. Now I'm supposed to put 10k resistor here to 3.3 volt, but I won't do that because I will be wasting resistor. This microcontroller have something we call pull-up resistors. You understand? I've mentioned that in my previous video, pull-up resistor. So I have enabled the pull-up resistor in the program. So why a pull-up resistor? Very important. For this is a push button. Now you need to set this microcontroller pin to a default state. So I want this pin now to be in logic 1, so which means I have to be enabled the internal pull-up resistor. So which means if this button is not pressed, pressing this button, you are short-circuiting this terminal to ground. You understand? Which is going to be 0 volts, which will be logic 0. When the button is not pressed, this pin will go high into logic 1. So as long as you press, this button is pressed down, the microcontroller is going to detect logic 0 on this pin. So you now tell the microcontroller, hey, this is what I want you to do. If you detect logic 0 on this pin, I want you to flash this LED. As you are flashing this LED, also check this pin. If this button is not pressed and you flash this LED 10 times, I want you to deactivate this relay. But as long as this button is not pressed, if this button is not pressed, turn on this relay. This relay should be on. So that is the way you program this. This relay should be on as long as this button, this point here, this pin here, PB3 is on logic 1. As long as this input here is logic 1, send logic 1 here. So me input here logic 1, the output here is logic 1. So once there is logic 1 there, it means that the relay will be on. But once the microcontroller detects logic 0, as long as this pin is on logic 0, your microcontroller is going to, after flashing this in 10 times, is going to turn on this pin here to activate the transistor. Transistor will now drive the relay. So it will continuously still checking the pin, but as long as the pin remains on that logic 0, this relay will remain on. You understand? So the moment this pin go back to logic 1, this output here will be logic 1. But as long as this one remains on logic 0, this pin here will be on logic 0 as well. So once this pin is on logic 1, this pin will also be on logic 1. You understand? Now, if this one is on logic 0, it means that the door is closed and you start flashing this LED, and at that time it detects logic 0 here. It will pause from what it wanted to do. That means it will allow this pin to remain logic 1, which means the relay will still be on, which means there is power supply to your load. You understand? Now, the moment you open the door again, the sequence is going to start all over. So that's how you. Now, before you design anything embedded system, you should have known how analyze the way you want the system to work. So based on that, now you can now be able to sit down and develop your program. You understand? You can now sit down and then develop your program and make it work the way you want to work. You understand? Now, since I have 12-volt relays around us, they are much more available, so that's why I use 12 volts. So which means I'm powering the relay 12 volt DC is easy to get around easily, so that's why I use 12 volts so that I can power my 12-volt relays. You understand? So the relay, you can use it if your load is less than 15 amps. If your load is less than 15 amps, you can just make sure, if you are putting this in up permanently, make sure you use larger cables. You understand? Based on your requirement. You understand? So for real life, you want to put it in permanently, make sure your relay, the size of your relay should be twice more higher than the total load that you are using. You understand? So so that is all we have for today. So we'll be closing here. So please, just like as I've said, please make sure to subscribe and make sure to share this video. That is, if you benefit from it, please share it. Also go and I want to see you make your own version of this. Please go and try and make yours. Thank you. See you in our next video.